Okay, so for the singularity question, we have a reverse triangle. We need to calculate RA and RB first, but I don't got time for that. So RA equals 11 over 12 WL, and RB equals 7 over 12 WL. So we know that. And you know how like my trick for the triangle was, if it's going down, like you use the formula to do it, and then you add it back at the end, and then you add like the rectangle part. But it doesn't work for this because that only works for when it's like this. So to make it work like that, you start here and then you do your functions that way. So let's do that. So we have d2x over dy squared ei equals, so we have RB going up. So we know it's 7 WL over 12, and it's a point load. So we have x minus 0 because it starts there. Then we have this WL. So minus WL x minus L to the, x minus L to the 1. And then we reach our triangle. So now we can use our trick again. So we know that we need the slope, right? Yeah. So slope is m equals W over L. And then the formula was m over 6. So it's going down. So we use my trick. We subtract W 6 over L. Yeah, because it's m over 6. X take away L to the 3. Just follow the formula. And then we get to the end, and so we add it. W6 over L, X take away L, and no, not L. This happens at 2L, 3. So memorize minus add, and then we have to add back like the rectangular part. I just memorize this again. Like I don't know why we do this, but we just do it. And so it was the intensity. You just follow the rectangle formula, which is intensity over 2 x minus 2L over 2. That's in the formula sheet. So yeah, so we do minus plus plus. We're done with the triangle. Then we have to consider the RA, which is plus 11 over 12 WL, x minus 2L, linear, so 1. And then we integrate this. We get dx over dy ei equals 7 WL over 24 x minus 0 to the 2 minus WL over 2 x minus L 2 minus W24L x minus L to the 4 plus W over 24L x minus 2L to the 4 plus W over 6 x to 2L minus 3. And then finally plus 11 over 24 WL x to the 2L to the 2. So we have those. Make sure your symbols are like still good, plus, plus, negative. Yeah, they're good. Oh, I have to add my C1, plus C1. And then y times EI, integrate again, get 7WL over 72 x. I'm just gonna take out the 0, it doesn't matter anymore. WL over 6, x take away L to the 3, take away 5 times 120L, x take away L to the 5 plus W120L, x take away 2L to the 5 plus W over 24, x take away 2L to the 4. This takes so long. Plus 11 over 72 WL, x minus 2L to the 3 plus C1x plus C2. So we have that, and then when x is 0, y is 0, because we have a support here and a support here. So deflection is 0. Okay, so when you just put in 0 for all of these, it becomes, you get C2 equals 0. So C2 is gone. Now we need C1. We need another boundary. We have at x equals 2L, y equals 0. And remember, we're going this way now. This is our direction. That's our direction. And so we have, when you put everything in, you get 0 equals 7WL over 72 times 8L to the 3. Like we're putting it into this equation, right? 8L3 take away WL over 6, L3, 2L, and then we have this one. Take away W over 120L, L to the 5, and then L minus 2L, none of these matter. We don't need to do these. We don't need to do those because L, we only do positive for a singularity. But we have our plus C1 X, so 2L. Then we can solve for C1. You should get negative 217 over 720. If I got that on an exam, I would think it's wrong, but that's what you're supposed to get. For C1, you put it back into your equation. You get, I don't feel like writing that all down. I'm just going to copy it. I'm just going to copy it. Okay, we get that. C1 is negative 217, 720 WL3 times X. And then we want deflection at C. So YC, C is, that happens at X equals L. Yeah, when you put everything in, you can do it yourself, but you end up getting, like your last step should be YCEI equals 7WL4 over 72 minus 217 over 720 WL4. Then you should get YC equals negative 49 over 240 WL4 over EI, and that's the correct answer.